Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week in Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science. Our lead story today concerns a very gloomy UN report concerning global warming. Unless we heed the message of thousands of scientists, say the United Nations, we're headed for a new normal, where sea level rise, gigantic hurricanes, droughts, famines, forest fires, you name it. The Earth is going to be afflicted by these things, but there is a glimmer of hope. The paper also mentioned that if certain measures are taking place now, then perhaps we can blunt the worst effects of global warming by 2050. Well, we'll wait and see. And talking about the weather, the United States had a 1-2 punch in the South, where Hurricane Florence and now Hurricane Michael have created tremendous havoc. Florida, the Carolinas, Georgia, devastated by 100-year hurricanes. Hurricanes that you have to go back into the record to find anything comparable. And yet, here we are in a hurricane season with, yes, many weeks to go. And perhaps there could be more hurricanes lurking out there. And the question is, well, the obvious one, is there a link to global warming? And then let's talk about outer space. First of all, we had a near disaster in Kazakhstan, where the United States piggybacks on the Soyuz spacecraft in order to send our astronauts to the space station. It turns out that the launch had to be aborted just a few minutes after launch, and the astronauts could have perished. However, the Soyuz spacecraft had a special ejection mechanism, and they were able to parachute back down to Kazakhstan safely. We had two disasters with the space shuttle. 14 astronauts perished. And the question is, do they really have to die? I mean, we saved the astronauts just the other day. But the question is, why didn't we do that for the space shuttle? And speaking about outer space, let's say a few things about new discoveries in the universe. First of all, we now know that there is a Jupiter-sized planet out there called Kepler 1625b that has a moon going around it. Who would have thought? Not only can we detect extrasolar satellites, we can now detect satellites going around these satellites. That's how accurate our instruments are. And speaking about the solar system, there's more planets and objects out there to be discovered. First of all, there's a new object called the Goblin, discovered during Halloween. The Goblin, which is near Pluto size, lurking out there in the heavens, and that points to the existence of Planet X. So let's talk about a new entry into our solar system. And then the Nobel Prize. The Nobel Prize, of course, has been mainly awarded to men, but hey, in physics and other disciplines, women are catching up. In particular, 3 people won the Nobel Prize in physics for improvements on the laser, and one of them was Donna Strickland, a woman. And it points to the fact that in the history of the physics Nobel Prizes, this only marks the third woman to win the Nobel Prize in physics. And speaking about physics, Einstein's God letter is up for sale. That's right. Earlier, it sold for $3 million, a handwritten manuscript of a letter that Einstein wrote concerning his ideas about God and religion. Well, that's big news. Previously, it sold for $3 million. Some people say it will sell for even more when it's up for auction. Well, let's just jump right into some of the top stories of the past week. The big story concerns the weather. In South Korea, the United Nations assembled a team of scientists. 90 scientists wrote this report. It was peer-reviewed by 6,000 scientists, and it predicted that in the future, temperatures could rise by 1.5 degrees centigrade by mid-century. Now, that doesn't sound like much, but realize that in the last century, the last 100 years or so, temperatures on average rose 1 degree Celsius around the Earth, and now within a matter of just a few decades, it's going to rise again 1.5 degrees. And this, of course, is going to have substantial effects on the weather. It's going to affect you and me and the economy. First of all, sea level rise. Sea level rise does not necessarily result from the melting of the ice caps. No. Most of the sea level rise is due to the fact that the oceans are warming up. Because the oceans are warming up, hot water expands. And as hot water expands, sea levels rise. And we can measure that very accurately because we know to the millimeter the level of seawater over the past decades. And yes, it turns out that island nations will disappear by 2050. And not only that, but major cities could have to have dikes and levees surrounding them, or else they will go either underwater or gigantic storms will hurl tremendous amounts of water over the dikes, flooding these cities, making them uninhabitable. For example, if you take a look at Manhattan, where I'm taping this conversation, it turns out that lower Manhattan probably will be underwater in the coming decades, and that's where Wall Street is located. And already there's some talk about building super dikes and levees around Manhattan, or else the economy of a good chunk of the USA could literally go underwater. And speaking about going underwater, the North Polar region is also thawing. Large parts of Canada, Alaska, Siberia are thawing out, and as they thaw out, they release methane gas. Methane gas frozen in the permafrost for tens of thousands of years, and now coming back. In fact, that's one of the reasons why in science journals, you'll notice that prehistoric carcasses are being found in Siberia, carcasses of Ice Age mammoths. And why? Because of the fact that they were locked in the permafrost for thousands of years, but the temperatures changed, and therefore they're thawing out. So we're seeing a change in the ecology of the North Polar regions. And the South Polar regions, I remember when I was a grad student, people would say that the South Pole is as solid as rock. Nothing known to science can cause the South Pole to melt or even crack. Well, it's cracking. It turns out that we see huge chunks of the Larsen ice shelf beginning to break off. Pieces of ice the size of Delaware are breaking off the Antarctic, and this was not supposed to happen for centuries or thousands of years. And then droughts, famine, flooding, forest fires, a new normal could be emerging. And this is something that's going to affect everybody, you, me. At the very minimum, it means that agricultural prices are going to rise because of the fact that foods cannot be grown cheaply because of droughts, famines, and flooding. That's going to affect the bread baskets around the world. Now, we're witnessing essentially a new normal with regards to the weather. New heat waves simultaneously with new flooding, a new normal. 100-year storms, 100-year droughts. That's the new normal. And speaking about that, the United States was hit with a 1-2 punch. Hurricane Florence and Hurricane Michael. In fact, people in the Carolinas were hit twice by these hurricanes. And it's very easy to say, aha, it's global warming. Well, it's a little bit more complicated than that. First of all, you cannot say with certainty that any one event is caused by global warming. No, that's not the way the weather works. There's no smoking gun where you can say that this temperature rise was caused by this hurricane. However, what you can say is that on average, you can predict the future. On average, it means, for example, more powerful hurricanes. For example, where does the energy of a hurricane come from? It comes from warm water. And that's exactly what we're seeing now. Temperatures rising in the Caribbean, and that's the fuel that makes gigantic hurricanes. Hurricanes start as a sea breeze off the coast of Africa. And as they go across the Atlantic, they build up more and more energy. And as they hit the Caribbean area and the Gulf, That's the fuel. The hot air is the fuel that makes these gigantic hurricanes that come barreling into Texas and the Louisiana and the Carolinas. And because the temperature on average is rising, it means that you can predict that on average, hurricanes will be more fierce. And this also means more forest fires, more droughts, more famines, you name it. We're talking about extremes in weather. Now, global warming in some sense is a misnomer. The Earth is not heating up uniformly. In one area, you could have a drought. In another area, you could have flooding. And then people laugh at the scientists and say, see, I told you so. Right in the middle of a summer, there could be a cold snap. No, we're talking about an average phenomenon. That yes, all the arrows on average point up. More droughts, more famines, more flooding, more forest fires on average. But you cannot say that any one particular event was caused by global warming. But on average, watch out. Well, let's now turn our attention to outer space. We had a near disaster recently in Kazakhstan. First of all, the United States, President Barack Obama phased out the space shuttle. Therefore, how do we get access to the International Space Station? We piggyback on the Soyuz spacecraft in Kazakhstan. That's right. That's one glimmer of cooperation between Russia and the United States, which is the space program. Well, we almost had another disaster when the booster rocket failed and they were able to abort the mission and eject the astronauts, saving them, and they parachuted back down to good old terra firma, back to Kazakhstan. What a feat of engineering. Then you have to ask another question. Now, jet pilots have a button, an ejection button, that even traveling at tremendous velocities, they can literally escape the dying jet aircraft. Why can't we do that with rockets? And the answer is, well, we can. So why didn't we? We had 14 brave astronauts, 2 space shuttles, literally explode on national television, exposing the weakness of our space program. And why didn't we have an ejection mechanism? I mean, duh. It's not that difficult. I mean, it costs money. But why didn't we do it? It cost the lives of 14 brave American astronauts. Well, that's what it is. Money. It costs money to build this ejection system. And that's the reason why we didn't do that for the space shuttle. Now, physicists have looked back at the space shuttle. Why was it not the gleaming success? It was supposed to be a space taxi, a taxi that would take us into outer space every week, reduce costs, open up a new era of space travel. Well, never happened. Each shuttle launch cost almost $1 billion. Let me repeat that. Almost every space shuttle mission cost $1 billion. That is huge, gobbling up the NASA budget. For science, not really. We could have shot payloads on single rockets much cheaper than using the space shuttle. So what happened? Well, Freeman Dyson at Princeton says the following. Look at the railroads of the 1800s. As more and more people began to use the railroads, there was a problem. Freight and people don't mix very well, and so the railroad system split in half. One half of the railroad system began to cater to passengers, making cheap, comfortable tickets for the trains. The other half didn't have to be comfortable. It was basically freight. And they specialized in creating a cheap transport system of massive amounts of cargo. So we had a splitting of the railroads. But the problem was the space program never split. The space shuttle was everything for everybody, which eventually meant it was nothing for nobody. In other words, it was part cargo, part astronauts, with tremendous costs. If we would have had rockets just for astronauts, it would have been cheaper, more streamlined, and then, of course, you could haul tremendous cargo missions into outer space with a second system. But unfortunately, the space shuttle became one thing for everybody, and therefore one thing for nobody. Costs skyrocketed. Instead of being launched once a week, it was launched once every few months. And then we had those 2 disasters in outer space. What happened there? Well, we think of space travel like a Sunday picnic. We go there for an afternoon and come back a few days later. Ho-hum. Television ratings have been dropping steadily. Well, think about it this way. 1% of the time, you go up in space and never come back. That's right. 1% of the time, we have space failures in outer space. We're 60 years into the space age, and we cannot get the failure rate down below 1%. That's just the way it is, folks. There's so many moving parts, so much high-tech machinery, and so much rocket fuel that 1% of the time, rockets blow up or fail. Now, think about it. We've had about 200 space shuttle missions. And how many explosions do we have? 2. So, right on schedule, in some weird sense, right on schedule, the space shuttle blew up on national television, and 14 brave astronauts died in the process, and they didn't have to die. We could have had an ejection system, but we didn't because of politics, because of costs, and excuse after excuse. You know, when we had the first space shuttle disaster, Richard Feynman, the Nobel Prize winning physicist, looked carefully and isolated the fact that the O-rings of the space shuttle did not function properly when the weather conditions changed and temperatures dropped to near freezing. And he demonstrated that on national television. But then, in his report, he did a science experiment. He assembled all the top engineers and bureaucrats of NASA in one room, and he handed out a sheet of paper for each participant in the room. And then he asked each participant, what is the probability of a disaster with the space shuttle? Well, most of the engineers said approximately 1%. That's the failure rate of rockets. I mean, hey, get used to it. 1% of the time, rockets blow up. But one engineer said something totally different. Instead of saying 1%, this engineer said, never. That's right, never. But that, of course, violates the laws of physics and probability. Never, he said. And then Feynman asked himself a simple question. Why? All these engineers were honest. All these engineers, except one, said the probability of failure is about 1%. One engineer said, never. What was different about this engineer? The difference was he got promoted from being just an engineer to becoming a manager, a bureaucrat, and his worldview began to change. Instead of being an engineer looking out for safety, he became a manager looking out for political expediency and cost-cutting. And it turns out that Ronald Reagan was supposed to talk to an astronaut in outer space by telephone, marking the success of the space shuttle. And so NASA rushed it. NASA sent that space shuttle into outer space, knowing that the engineers were hesitant because it was cold in Florida and the O-rings would fail. The engineers said, no, don't launch that space shuttle. But the bureaucrats said, well, the president wants a space spectacular. He wants to talk by telephone to outer space, to Krista McAuliffe, the woman astronaut orbiting the planet Earth. That was the game plan. Well, it backfired big time. And it just goes to show you that cost-cutting is one of the least important and most dangerous activities of the space program. Also, we have news from outer space. That's right. First of all, we're going back to the moon. Not only that, but not one, but two moonships. Two moonships could begin the process of reaching the moon. First, we have the SLS booster rocket, sponsored by NASA itself, scheduled to launch an unmanned probe around the moon at the end of 2019. So write that down. The end of next year, we're going back to the moon in an unmanned capsule. And after that, humans will go into outer space shortly after that. But not to be outdone, we have Elon Musk, who has his own plans independent of NASA. He has built not only the Falcon Heavy, which was successfully test-fired a few months ago. That is a moon rocket, fully capable of sending the Dragon capsule around the moon. But he wants to go even beyond that. Now he has a new rocket called the BFR, even bigger than the Falcon Heavy, which can go to the moon. And he's paying for it by himself. This is amazing. Private enterprise. Elon Musk is a billionaire, the billionaire behind PayPal, behind Tesla Motors and SpaceX. And he's selling tickets for the first moon rocket, selling tickets. And we had a buyer, a billionaire, Mr. Maezawa of Japan, a man who made billions creating the Amazon of clothing for the Japanese market. And he bought out the BFR. Now, what does the BFR stand for? Well, B stands for big, R stands for rocket, and F stands for, well, whatever your imagination will take you. So the BFR rocket is very interesting because it's not just a moon rocket. It's actually a Mars rocket. It will be the vehicle that'll take us not just to the moon, but also Mars. And so Elon Musk has a plan independent of NASA to go to the moon and eventually to Mars. Now, the press wanted to know, what does it cost? Well, they're not saying, but Mr. Maezawa bought out the entire capsule, not just one seat. He bought out all the seats on the BFR, and it'll take a few years to perfect. Now, the Falcon Heavy is already ready to go, but Musk wants to go to Mars. And so he's delaying it and creating the BFR that'll go to the moon and eventually to Mars. So we have two different game plans. The game plan of NASA is to create an orbiter, a lunar orbiter that goes around the moon, just like the International Space Station goes around the Earth. And from the orbiter, called the Gateway, NASA plans to launch a Mars rocket. Okay? That's plan one. But Elon Musk, not to be outdone, has plan two. His plan is, why bother with the lunar space station? What a waste of money. Why not go directly to the moon in one jump? One jump, beating out NASA by years. It'll take years for NASA to construct the lunar orbiter, but Elon Musk wants to shoot directly to Mars. Well, we'll see how it goes. Many people are saying that the final thing could be a mixture of these two possibilities, because, of course, space travel is not so cheap. Prices have been dropping, of course, but still, it costs a pretty penny to go to Mars. And so perhaps there'll be some kind of compromise between the NASA and the Mars program. And speaking about outer space, new discoveries about our universe. First of all, scientists have been analyzing a planet out there, 8,000 light years from Earth, called Kepler 1625b. It's a rather unusual planet. It's about a Jupiter-sized planet, but it has a moon going around it. That's right, a moon going around a planet 8,000 light years away. That's how accurate our instruments are. I mean, think about it for a moment. Our instruments are so accurate now that we can detect a distant planet going around a star 8,000 light years from Earth, and then detect a moon going around that planet. That's how accurate our instruments are. And it means that the universe is much more weird and much more strange than we thought. Our solar system is the exception. Our solar system looks quite normal. We have circular orbits going around the sun. But we now realize that that's the exception. That's the exception to the rule. And so we now know that our solar system is actually the oddball. Speaking about oddballs, new objects are now being discovered in our own backyard, the solar system. First of all, the Goblin. That's right. That's the nickname given to it by scientists, discovered around Halloween. And it is a chunk of ice and rock beyond the orbit of Pluto, about the size of Pluto. So we know there are large objects out there in what is called the Kuiper Belt, the Kuiper Belt of comets. Now, they're not really planets because they're small, they're mainly icy, and they lie in the Kuiper Belt of comets. So Pluto, sorry to say, is not really a planet in the usual sense of the word. However, if you look at the orbit of the Goblin, it wobbles a little bit, meaning that something is tugging on the Goblin. And if you use computers to calculate what is causing the gravitational wobbling of the Goblin, it seems to be, Planet X. In other words, a new gigantic planet out there. Now, at Caltech, using just computers, they were able to analyze the orbits of these objects, and these small objects in the Kuiper Belt wobble a little bit, and they predicted the existence of a new Neptune-sized planet out there. Now, it was not supposed to be that way. The Kuiper Belt was supposed to consist of comets, small debris, small chunks of ice, the biggest chunk being Pluto. But now we have Planet X. And so, even though we have not observed Planet X, we know of its existence because of the slight perturbations in the orbit of other planets like Neptune and like the Goblin. And so our instruments, once again, are so accurate when coupled with computers that we can find all sorts of anomalies in the universe. And speaking about anomalies, one system that is causing a lot of interest, discovered a few years ago, is a TRAPPIST system. 7, count them, 7 Earth-like planets going around a star. Now, it was not supposed to be that way. In our solar system, we just have the Earth, which is Earth-like, which is Earth-size, going around our sun. Venus and Mars are, quote, outside the Goldilocks zone, where you can have liquid water oceans. Well, it turns out that in the TRAPPIST system, we have 7 Earth-sized planets. It wasn't supposed to be that way. And of the 7, 3 appear to be planets that are sized just right, that they could, in fact, harbor life. And speaking about life, the Holy Grail of all of this is to find a doppelganger, a twin of the Earth in outer space. So far, we haven't done that. But already we have a handful of very likely candidates that resemble the Earth but are a little bit too big. However, it's now believed that because we find so many planets, and because we have a new orbiter out there looking for them called TESS may one day find the Holy Grail of astronomy, and that is a twin of the Earth in outer space. And then we'll ask another question. Who lives on that twin? Well, unfortunately, that's it for exploration. Good day.